Let's get started. So you got your homework back via email. I answered questions for people who emailed me questions. Hopefully you got those. If you need further follow-up, feel free to shoot me an email and I will be more than happy to reply. That was the first thing. Second thing is the next homework assignment from chapter 12 is due, I don't know when, hang on, is due next Wednesday. It should be next Wednesday. Yes, next Wednesday, May something, 6th. That sounds right. Okay, so that's chapter 12. And then remember chapter 13 is due kind of sort of at the final exam. We'll keep the deadline as noon just because we've been doing noon since we've gone to online. So we'll keep it that way. So that'll be Monday, May 11th, which is, I keep saying final exam and it isn't really, but just a test. Anything for logistical questions before we get into more function stuff today? Anything? Lauren, yeah.
So are you going to have, like, I know you have virtual office hours, I think, like on Tuesdays.
Yep.
Are you still going to have that like next week, or
Yeah.
are there going to be more opportunities beyond that?
I don't know that I'll necessarily set up anything extra, but if you have a time when you want to ask questions, you are certainly more than welcome to shoot me an email and we will find a time. So I'll probably do it individually versus saying, here's my set office hours in addition, but I have free time. So if you want to assign a time, we can absolutely do that. I'm just going to do it on an individual basis, I think. Yeah.
Thank you.
Other questions? Anything else logistical before we get going? Okay, so quick review of functions and where we were at. We had these new terms last time, injective, surjective, bijective, right? So we had these three new terms. Let's put them up. So remember, this is my recall, that F goes from A to B. And first of all, it's injective. If you could do this one of two ways, X not equal to Y implies F of X not equal to F of Y, or F of X equals F of Y implies X equals Y. And remember, I should have said this at the beginning. This is for all X and Y living in the set A in your domain. So that was injective, right? We did a bunch of examples with that yesterday, Monday. I assigned some homework problems, and the homework problems, I hope this was clear. The homework problems had both injective and surjective. We haven't done surjective yet, so that's what we're going to do today. Hopefully you just did injective on the homework problems so far. Surjective, which we didn't talk about, we just did the definition. If for all, I might be using different letters today than I did last time. For all B living in capital B, there exists an A living in capital A, so that F of A equals B. Did I use A and B last time, or X and Y? A and B, give me a thumbs up, or X and Y, what did I use last time? You don't remember, we don't care. We're fine, don't worry, don't look back at it, it's fine, no problem. We'll use these letters, we're good to go. So injective, surjective, and then bijective. And remember, this one is easy as long as you've done the first two. Bijective if injective and surjective. Okay, and remember there are also shorthand ways of saying each of these. Injective is one-to-one, surjective is onto, and bijective is usually referred to as one-to-one and onto, or if you want to be fancy, you can say one-to-one correspondence. Both get used, but one-to-one and onto is just a little bit easier to say. So today, plan for today is to do surjective examples. These are harder, kind of. I'm going to give you hopefully a process that will make them a little bit easier to deal with. We'll see. I tried this process out the first time I taught this class 2 or 3 years ago, and it seemed to work out okay, but we'll try it. We'll see what happens. And then hopefully we're going to get into 12.4 just a little bit with function composition, which by the reading assignment looked pretty familiar. So let's do an arrow diagram first. So really quick arrow diagram. Let's say that F goes from the set A, B, C, D to the set 1, 2, 3, 4. So my set A is lowercase letters A, B, C, D, and my set B is the numbers 1, 2, 3, 4. So we can do this with an arrow diagram. A, B, C, D, and we'll put 1, 2, 3, 4 over here. I don't know, I'm just gonna draw in some arrows. A can go to 1, B can go to 1, C can go to 3, and D can go to 2. We'll do it that way. A goes to 1, B goes to 1, C goes to 3, D goes to 2. A goes to 1, B goes to 1, C goes to 3, D goes to 2. Surjective or not? Give me a thumbs up or a thumbs down for surjective. Yes or no for this one. Thumbs up or thumbs down. What do we got? People are giving me thumbs down who are finished copying. Yes. So this one is going to be not surjective. Not surjective. Because, and there are a bunch of different ways that you can say this. The element that doesn't have a pre-image is 4, right? So 4 lives in 1, 2, 3, 4, but 4 has no pre-image. So that's kind of, in this case, it's obvious in the examples that we do when F is defined with a rule, it's gonna take a little bit more work to explain why something has no pre-image. But in this case, it's pretty obvious that 4 has no pre-image, right? We can see it, it's pretty clear, no big deal, all good. All right, those are the easy ones. Let's get into some where functions are defined by rules, and they're a little bit harder. All of these are prove or disprove surjective. So prove or disprove surjective. First of all, F is going to go from the integers to the integers, and X is going to go to X squared. From the integers to the integers, and X is going to go to X squared. So for this one, I won't do my scratch work because this one's hopefully easy enough to see. We're gonna do the scratch work for the next one, maybe. So what do we think? And this was the one on the reading assignment from a couple of days ago. Surjective, yes or no? Thumbs up, thumbs down. What do we have for surjective, yes or no? I'm getting some thumbs downs with no. So this one's not surjective, you're totally right. That means I need to find something that does not have a pre-image. So we'll say B equals, I don't know, -4 has no pre-image. And this needs a little bit more explanation. So we've got to do a because here. Because there is no A living in the integers, so that A squared is equal to -4. A squared is F of A, right? That's my F of A squared in this case. So there's no A that lives in the integers, so that A squared is equal to 4. That, I think, is common sense. If you put that up there, a reader would say, oh yeah, that makes sense. I can't square a number that's an integer and get something negative. So it's kind of a line to draw for these, where there's stuff that's common sense and where there's not, kind of in sort of a line to be drawn. You're gonna have to feel it through. I'll help you, hopefully, but I would say over-explain as opposed to under-explain if you're not sure. Okay, stop sharing for just a second. Questions on that? I think Lauren has internet issues, we'll see. Questions on that? Anything? So far so good? Grace, question.
Can you go back to the slide quick so I can copy the rest down?
Yes, I will. Yes. Yep. Anything? Questions? So far, so good? Okay, let's go back to the slide. Something happened with my sharing right now with my whiteboard, and I can't see all of you. Normally I can, and now I can't, and I don't know why. Okay, we'll do it like this. So there's my first example. No pre-image for -4. All right. Next up, for example, f is going to go from the real numbers to the real numbers, and x is going to be sent to 3x plus 2. X is going to go from the real numbers to the real numbers, and x is going to get sent to 3x plus 2. This is the first one where we're going to do some scratch work and hopefully help us out for prove or disprove. I'm not sure yet whether this is a prove or disprove. I don't know. So we're going to do some scratch work and see what we can come up with. This is not a part of the proof. You can keep it on your homework if you want to. That's fine. But I don't necessarily need to see this on your LaTeX proof, for example. So this can go on your handwritten part if you want to show it to me, but I don't need to see your LaTeX part. So here's what we would need. We would need f of a to equal b, right? That's our requirement. F of a would have to equal b. Or in other words, we would need 3a plus 2 to equal b. That's my f of a in this case, right? 3a plus 2 equals b. If I solve for a, I would need a to be b minus 2 divided by 3. That's what I would need. Everybody clear on why that's what I would need? I'm trying to find a preimage. Okay. Are there any problems with that? I am subtracting and I am dividing, and I'm working in the real numbers. Are there any problems with subtracting and dividing if I'm working in the real numbers? Thumbs up, thumbs down. Any problems with subtracting and dividing for the real numbers? Yes or no? What do we got? Any problems with subtracting and dividing in the real numbers? People are giving me a thumbs down, no. Dividing would have a problem in the integers, right? We're gonna come back to that in a minute, but in the real numbers, no problems. So here, there are no problems if A and B live in the real numbers. Integers, maybe. Real numbers, no. No problems if A and B live in the real numbers. So therefore, we can say yes, surjective. And here's what our proof needs to look like. So remember our definition, right? There exists an A living in A. So we can choose A to be whatever we want. This is an existence proof. We're choosing A. Well, that's fantastic because our scratch work told us what to choose A to equal to. So we can say choose A equals B minus 2 over 3, which lives in the real numbers because B lives in the real numbers, and we are using subtraction and division. Okay, again, division is a problem with the integers. It's okay for the real numbers right now. Sorry, I ran out of space and I'm doing poor whiteboard work. Here we go. So then what we need to show is that f of a equals b. All right, this is an equation. I have yelled at you about this all semester. Start on one side, work your way to the other side. So we know that f of a is equal to 3a plus 2. And then I picked an a, so I can plug in. So this is 3 times b minus 2 over 3 plus 2. That's what I picked my a to equal. So if we do some multiplication out, we've got b minus 2 plus 2, which is equal to b. That's good. Actually, I don't earn a smiley face yet because I got to finish my proof and say therefore. But that's good. That's what I wanted. That's what I wanted my equation to be. And we can say therefore, f is surjective as desired. And then I can earn a smiley. Grant, question.
I'm a little confused on actually the last example you have.
Okay, hang on one sec. Let's finish this one and then we'll go back to the previous one. Questions on this example first. Anything there? And we're going to do a couple more where we've got the scratch work and we're going to look if there's problems or not. But anything for questions on this example first? Okay, then Grant, let's go back to the previous one. Yes.
Never mind, I figured it out.
You good? You sure?
Yeah. Yeah.
Okay. All right. Ready for another one? All right. Let's try another one here. How about this one? What do we have? Let's do, for example, F is going to go from the real numbers without 0 to the real numbers. All right. And we are going to take an element x and send it to 1 over x plus 1. Sorry, wrong button. Sorry. X is going to get sent to 1 over x plus 1. And we want to know whether this is surjective or not. So let's do some scratch work. So here's what we need. We need f of a to equal b, or in this case, we need 1 over a plus 1 to equal b, right? That's what I need in this case. 1 over a plus 1 has to equal b. That's my f of a. All right, so let's do some solving for a. 1 over a has to equal b minus 1, and then I can flip both sides. So a needs to equal 1 over b minus 1. Are there any problems in this case? Remember, b is coming from the real numbers. Any problems? Any issues? Grant, you're nodding at me. What is a b value that gives me a problem in this case? This has a problem if b equals, Grant?
1.
Absolutely. Problem is b equals 1, and that really truly is a problem because 1 lives in the real numbers. So not only do you have to identify if there's a problem, you have to check and make sure that that problem actually is coming from your codomain. If you have a problem for some numbers that aren't in your codomain, then it's not really a problem and you're fine. But in this case, we got a problem if b is equal to 1. So here's how we're going to prove that. This is a no. So we would say it's a disprove. You don't have to write disprove, but I'm writing disprove because I want to go back to our original statement first. So this one's a disprove. And then remember what our surjective definition looks like. For all b living in the codomain. That means a disprove needs a specific counterexample. Yes, if I'm disproving a for all, I need a specific counterexample. So I am going to say choose b equals 1. That was where we found a problem. And then we would need a to be equal to 1 over b minus 1, or a equals 1 minus 1 over 1, or a equals 1 over 0. But that doesn't work. That's a contradiction. And that is, actually, let's not do contradiction. We won't do contradiction. We're going to do it this way, which does not live in the real numbers without 0, right? A is supposed to come from my domain, from the real numbers without 0, but 1 over 0 doesn't live there. So therefore, F is not surjective as desired. Since it was a prove or disprove, doesn't matter which one we do, we just got to do one of them. So the scratch work helps, hopefully, because the scratch work helps you determine, is there a problem, is there not a problem? I'm not sure. I don't know what's going on, so I'm going to do some scratch work to see if I actually have a problem or if I do not, in fact, have a problem. Does the difference between this one and the scratch work for the proof in the previous one make sense? Questions on either of these before we do another example? Any questions here? Okay, let's